In this video, we are going to learn about a lifecycle method called shouldComponentUpdate. So earlier, we learned about lifecycle methods, which are component did mount, component did update, component will unmount, something like that. But there is also a lifecycle method in class-based component, which is called shouldComponentUpdate. Okay. Now, what is this lifecycle method? So you remember that earlier we said that there is something called React.pure component. Apart from React.component, there is something called React.pure component also. So the difference between React.component and React.pure component is exactly the implementation of shouldComponentUpdate only. The shouldComponentUpdate says that when this component should render and when this component should not render. So this, if this shouldComponentUpdate, this returns true, okay, then this component will re-render when there is any change in states or prop. Okay, so for example, actually it has arguments which is like next props and next state. Okay, and we are right now not making use of it, but what is actually happening, that let's say right now count is 0. Okay, now let's say you change count to 1. Then after that, before the component is being rendered, this function will be called, this lifecycle method will be called, and in that this dot state dot count. So here when this will be called, then at that point of time, this dot state will be the current state, and whatever you have just updated, that will be the next state, which means that let's take the example of count. So if count you change to 0 to 1, then what will happen? This dot state dot count will be 0, and next state dot count will be 1, and this will be before the component is re-rendered. In fact, here only we are deciding that, you know what, earlier means actually the current becomes earlier, because here you remember that in component did update, previous props and previous state is passed, right? But here next props and next state is passed. You try to understand what is the difference. In component did update, the render has already happened. So render has already happened, then this becomes previous and the current becomes this thing. But right now the render has not happened. This is the function which is going to decide whether the render will happen or not. So in that context, the current count is still 0, and whatever you just updated before rendering, once it renders, then the new thing which you just changed, that becomes the current one, right? But this is just before the render, which means that whatever you are going to change, that is like next, and whatever is current, that is like that is in current only. Okay, so the difference, the comparison here happens between current props and next props. So this dot props and next props, and current state and next state, which means that this dot state and next state. So here, using these scenarios, we are going to see that whether we are going to return true or false. So you can have a lot of if and else or whatever, that does not matter. Every time when anything is updated, okay, then React will call this method, and then if it returns true, then it will re-render. If it returns false, then it will not re-render. By default means if you have not written anything, then by default it returns true. Okay, so I'm saying that, let's say you have not written anything, then by default it means that this thing is same as this, return true always, which means that you re-render always whenever there is any change. When there is any change means whenever it needs to re-render. It means that even if count has not changed, count 0 to 0, but this dot set state has been called, okay, then whether I want to re-render or not, no, return true, which means always re-render. When I return false, then it does not re-render. So I'm building on the example given before, where we are saying that there is a there is some prop which is being passed, and what is happening is that if you click name change, then actually this name is changing. And in one of the earlier examples we said that what we are going to do is that Alex and 2 times Bob. Okay, just to show that whether it is re-rendering or not every time. So let's see. So re-render, we saw that when Alex to Bob, then there is re-render. In fact, when I click again, then Bob to Bob, see, Bob to Bob, it has happened, which means that it has not changed, but still it has re-rendered, you see. And Bob to Charlie, then obviously it will re-render. In fact, this is a normal component, right? So whether you are changing anything, always it is re-rendering. Okay, does not matter what are you changing, always it is re-rendering. Okay, so either you are changing count, either you are changing past prop, either you are changing this my list, which is not a primitive type, which is an object type, which in fact it is an array, and you are pushing it. Okay, so this is the default behavior, whether you use this or not, this is the default behavior. But now if we want to optimize, then there are 2 ways, right? In one of the earlier videos we saw that for optimization we can use pure component, that is one way, right? But in fact pure component is nothing but a normal component with custom logic here. Okay, so now we are going to do what internally React.pureComponent internally does. So that's what we are going to do right now by hand. Just to tell you that whatever we are writing, that if you want to do then that we are going to simulate pure component, that then why to write, because it is already implemented. We simply use pure component and that feature comes to us out of the box. Why I am showing you this lifecycle method, this is rarely used, but you should use this only when simply React.pureComponent or that kind of optimization does not work. Means that works in general, but that does not work for your use case, and you want some customized behavior. Okay, so in that case you can specifically say here that true or false. Let's try to make this true false. Okay, and let's now change. You see that I am changing names, you see, but still in fact this is not rendered. This component, this whole thing is the component which is greeting 2, and you can clearly see that greeting 2 is being rendered every time, but definitely my div, this my div component, you can see that inside my div I have written this shouldComponentUpdate, right? So this greeting component is updated, but this my div component is not updated. Okay, so you can see that this is part of greeting component, this is updated, but this border, this thing is my div component. And you can see that even if I change state or change props, actually things are changing here also. When you are clicking, then inside that 0 is becoming 1, 1 is becoming 2, everything is happening, but you are not able to see anything because I'm saying that don't re-render, whatever happens, don't re-render. Okay, and that's why it is happening. Obviously you never want to do something like that, right? But then if you simply use something like this, then this is also of not much use, because then there is no point of using this altogether. By default this is the behavior. The purpose of this lifecycle method is that you do something yourself and you figure out some way of optimizing it on your own. Now again, we will start with a normal optimization, what React.pureComponent does, and then we will see that if we can do somewhat more customized implementation. But this is what sort of internally React.pureComponent is doing. Okay, so as discussed above, before, React.pureComponent does what? It does a shallow comparison of props and state, and if it sees any difference, then essentially it updates, otherwise it does not update. Okay, so what we are going to do is that first of all we are going to implement a function called shallow compare. It will take some old object, or let's say previous object, and some next object or like new object, whatever. Okay, and what it is going to do is that if they are exactly same, then it will return false, and So it has nothing to do with here. Let's comment it all together, right? We are right now not focusing here. We are right now just focusing that is there a difference. This thing is trying to find, is there a difference between these two past objects? Okay, that's what we are trying to see. Now difference in terms of value, not in terms of just base address, because base address is like plain and simple, right? This we will see simply that whether this thing is equal to, base address is equal to this thing or not. This is straightforward. That is not that much simple. What we are going to do here, we are going to do shallow compare, which means that if there is some object, something like this, let's say this thing is there, right? Then we are going to iterate over that object and then see. So for simplicity, let's see, we are doing something like this, that log, and we are printing something, let's say shallow compare, and then let's say the first thing is a5, okay, and the next object is, let's say, I don't know, same thing. Firstly try with same thing, a5. So these two, previous object and next object, these two are same. Okay, obviously their base addresses will be different because they are completely different, separate objects altogether, right? But still I want in this case to give me true. Okay, but if something like this is there, let's say instead of a5 a10 is there, then I want there is a change, so I want true. Okay, if there is no change, then I want false. A5 everything is, or let's say here also, let's say b10 means whatever is there here, and that can be, ordering can be different also, because we know that in objects ordering does not matter. So something like this or something like this does not matter. Even in this case, a is 5, b is 10, both are same, right? So there is no difference. So I want this function to return false in this case, but there is even slightest difference. So for example, here instead of 10, here it's 11 or 12, then it should return true, that yes, there is difference. Similarly, even if it is 10 and let's say some new thing c5 or c2 is there, okay, then again these two are not same. Why? Because it has an additional something. Okay, so if there is any difference, I want to return true, otherwise I want to return false. Okay, so how can we do that? We know that, and again we want to do the similar thing for arrays also. This is object, right? What we want to do for arrays also. Okay, so which means that 1 2 3, let's say, or let's say 1 2 3 5. Okay, then here also, if let me see, if let's say okay, so this thing will be there. So 1 3 5, this will return true because they are different, but let's say 1 2 3 5, then it will be same. Okay, so let's firstly keep this only, doesn't matter. So both cases we will see one by one, but let's just firstly start with the first one. What we are going to do is that we are going to do for in. Okay, what does for in do? What does for in do? For in gives us the key of the object. Okay, so let's iterate on the new object. Whatever is the key, if something like this, that if new object key is not equal to previous object key. So what is this? Essentially, key is just the item. So for example, it will be a b like that. Okay, key item, and then when I do corresponding array syntax, then this will give me the value. If this value corresponding to that key, if the value corresponding to that key in new object and old object, if they are not equal, then definitely I return true as soon as I get something like that. But if I have iterated through the entire loop and each and every value is exactly same, which means that return false. There is no difference. There might be difference, but that might be at some deep level. That also we will see right now. But at least on the face of it, on the face of it at the shallow level, there is no difference. Okay, so let's see if we can. Okay, so let's see. So we are printing true, which means that these two are different. True means there is change. Okay, let's remove this C2. Now see, it is saying false, which means that they are same, isn't it? Here also you see 1 3 5 and 1 2 3 5, you see that it true, which means that there is difference. Okay, but if I make it 1 2 3 5 exactly same, and you see it is false. So it is sort of working. Okay, now exact internal implementation inside React might be slightly different, maybe some more corner cases etc is handled, but overall this should be a working thing, which what we want to do. Okay, so shallow level, at one level it goes and it sees that whether they are same or not. Okay, now now let's see. Now what we want to do is that now we are going to make use of this function in shouldComponentUpdate. Okay, so what are we going to do? We are going to see that what is the first condition? The first condition is you know what, if I do shallow comparison of this dot props dot this dot props and next props, that is one condition, and another condition is I do the same thing with this state and okay. Then so what I am comparing the current props with the next props. I am comparing the current state with next state. If any of them is true, which means that, see, if both of them are false, if both of them are false, which means that there is no difference, I should not update, right? But if any of them is true, then I should re-render. So the thing should be something like this, isn't it? Okay, either props, there is change in props, or there is change in state. In both cases, please re-render. So you see that even if now this is a React.component, but you see the behavior, because I have implemented shouldComponentUpdate in such a manner, then you can see the behavior. If I change Alex to Bob, then you can see that there is re-render. If I click again Bob to Bob, there is no re-render. So now it is behaving like pure component, isn't it? If I again Bob to Charlie, then there is re-render because there is change. Similarly, 0 to 1, then there is re-render. 1 to 2, there is re-render. 2 to 3, there is re-render. But again, if I click, then 3 to 3, because we have put a condition here, right? That if it is equal to 3, then after that it does not increment that. Okay, so it remains stuck at 3. But every time I click, then you see that obviously this set state is happening, but re-render is not happening, because even if it is a normal component, the pure component behavior we have simulated like this. Okay, so you can understand that when instead of React.component you use React.pureComponent, then internally React is doing something like this, that they are implementing a shouldComponentUpdate like this internally for you, where they implement some shallow comparison method like this, and then they go and compare it like that. Okay, you see that the problem with my list will happen here also. You see that I click two times 0 should be inserted, but I cannot see it unless I change 0 to 1, then it is visible. Again, if I 3 times I click 1 1 1, then internally my list has changed, but it is not visible to me because it has not re-rendered. Once I click again, then you can see that thing is re-rendered. So the problem, the same problem which happened with React.pureComponent, the same problem is happening here also. And obviously that is sure that will happen, right? Because essentially right now we are sort of simulating exactly the same thing what React.pureComponent internally does. Okay, now here is the thing that, let's say I want to further customize it in some manner, so that I want to do something more, or some new type of comparison, okay, or let's say some new type of logic that when it should render or not re-render, right? Then that kind of thing I can implement on that kind of logic. I can implement my own, because now I have a fine grain control, more control, because I am implementing my own should component update. One thing I wanted to highlight is that this should component update is not used when during the first render and during the force update. So these are the two places when should component update is ignored. Means whatever you return, even if you return false, then also it will be re-rendered. Okay, re-rendered means rendered or re-rendered. So you understand that this is only done after first update or something. The first time when the component is rendering, then obviously it has to render, something has to render, right? So there is no point of using should component update. So that point, this should component update is altogether ignored. After that, there is a point where you do somewhere, let's say force update, this dot force update in your component you do somewhere, right? Then by definition force update means you just re-render forcefully. So in that case, this logic will not work, because I am saying that it should be forcefully updated. So whatever logic you are writing, that this will be overwritten, because I am saying specifically force update. Apart from that, one thing more is there, that you should not rely on this should component update for exact avoiding render or something, right? This should be like only for optimization purposes, which means that right now, let's say whenever you return false, then React will honor your false and it will not re-render. But in future versions, React might ignore, even if you're returning false, then let's say in some special scenarios it might think that no, some weird thing has happened, so I should still go and flush the things. So even if you return false, then also it might re-render a couple of times. So let's say out of 100 times, let's say one time or two times it re-renders, which means that it's not one sure shot rule that whenever you return false, then it should never re-render or something like that. You should only think it like a hint to React, that I want you to not do that, okay? But then for optimization purposes, but if React wants, then they can go ahead and do re-render again, even if you are saying not to do that. So so you should not take this in a very hard and fast rule, okay? So that is one point. Apart from that, right now it is a good time to show you one illustration. So if you go and Google something like React Lifecycle Methods diagram, then the first link which you will get is a beautiful diagram which is recommended by React project itself, where they are showing you that actually what happens at the phases of mounting, updating and unmounting. So this we already know, right? That while mounting, constructor is called, and then render will happen, right? And then component did mount will be called. While anything is updated, state or prop is updated, then at that point of time, obviously constructor is called just once while mounting. When anything is updated, then only render will be called, and then component did update will be called. And finally, when the component is unmounting, then component will unmount will called. So will be called. So this we already know, right? If you click on this checkbox, then some new lifecycle methods will be coming, which are not that much used, which are less common lifecycle method or rarely used lifecycle methods. Okay, some of which we are discussing right now. Okay, so right now, if you check that, then right now we are discussing should component update. Okay, so and all of them, so maybe we'll get snapshot before update also in some videos, but you don't need to go through all of them, because some are obsolete and some are very rarely used. So anyways, most of the obsolete things are not even mentioned here. So unsafe underscore some lifecycle methods you will see. So those you should avoid it using in almost all cases. Okay. So yeah, so should component update if you see, then this is exactly what I said, right? That before even render has happened, before that even should component update is called. Even it in fact this cross thing means that if you return false, then it will not re-render, and if you return true, then it will render, okay, and go ahead, and then after that it has rendered, then it will do component update. Okay, so so you can go and have a look at this thing. Okay, so yeah, again, this is a like should component update is a rarely used method. You will rarely implement it on your own, because for minor optimizations you will simply use pure component, or there is something called only for comparing props you can use something like react.memo, which we'll discuss later. But the point is that just in interviews they can ask you something like this, even if you have not implemented on your own, that like you can do something, some weird thing. So for example, let's say um, if uh, if let's say if if next props, next state dot let's say, I don't know, my list dot length, that is an array, right? My list is an array, right? If this length is greater than 5, then no matter what, always return true. Just I'm just showing you an example, that some weird thing you can write. Okay, so if it is less than 5, then it will not re-render, right? But less than or equal to 5, but or let's say less than 5, and as soon as it becomes 5, after that you can keep on it will automatically keep on re-rendering. Okay, which means that its behavior will become pure component if it is less than 5. If length becomes greater than equal to 5, then the behavior of this component becomes like normal component rather than pure component. Let's see that. You can see that, let's say 2 times I clicked, and then you can see that it is nothing is changing, because it is like behaving like pure component. Okay, and then when I click this, then it is updating. Similarly, let's say 2 times more I did, then it is like still the length is 4. Okay, but now you see that after 5 it is rendering. Even if I don't need to click this to re-render or something, it is automatically working, right? Because of this thing. So just you understand, like now once you understand that you can have any logic here, and then return true when you want to re-render, return false when you don't want to re-render. That's all. That is the logic, whole logic. Okay, based on that you can do your custom implementation in case you need it. By the way, rarely you will use that, but in interviews they can ask you something like that. So that will be all for should component update. We'll see some other concept in the next video. So that will be all for this one. Thank you.